So yesterday was maybe a little bit tricky, right? And so what we're going to do today is I'm just going to try and break down exactly what you need to do in order to evaluate trig functions without a calculator. Okay, so again, for those of you that are planning on going on to pre-calculus or calculus, even algebra 3, you'll probably see this again, okay? And so it's important to try and get it down now. I know it's kind of difficult just because, we're here doing this, distance learning, and I have to kind of like try and make this as simple as I can. I don't have a whole lot of time to do this. My videos are short, so I apologize. I really don't feel like this is easy to do with what with what I'm trying to show you here. It's not an easy topic in the first place, let alone when you can't sit there and easily ask me questions and I can't see your faces and we can't pause and I don't know have time for questions and stuff like that. So please continue to message me and then we'll figure something out. Okay. So anyway. So here's my basic steps that I have laid out for you about how you're eventually going to evaluate trig functions without a calculator. Okay, all that stuff yesterday was kind of just like showing you where that comes from, but I'm just going to show you basically how to do it. Okay, and if you want to learn more, if you want to really try to understand what was happening yesterday, if you don't feel like you understood it that well, let me know, and I'll be happy to try and explain it better for you too. Okay. All right, so again, our goal is to evaluate trig functions without a calculator. Now, we are going to be limited in what trig functions we can evaluate. Okay, so we won't be able to, for example, find what the tangent of 21 degrees is. Okay, that's not possible. We won't be able to find, the sine of, negative 80 degrees, for example. Okay, at least not with this technique we're doing. Okay, these you're going to have to use a calculator. Okay, because there's just no way to do it. So what are we able to do? Well, we're only able to evaluate trigonometry where we are able to evaluate using the 30, 60, 90 or the 45, 45, 90 special right triangles, okay? And especially for those of you guys that are learning it, I would encourage you that, every time you go to do some problems involving evaluating trigonometry, that you draw out these two triangles, just like I have them drawn here, okay? It's slightly different than the one that I showed you, yesterday's lesson. In the previous lesson. And then also, if you want to, you can also draw this, which is just showing you, like quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And it gives you an idea about what functions are positive and where. Okay, so anyway. Okay, thank you. I'll be right back. Let's go through a practice problem here. So, for example, sine of 45 degrees. Okay, now sine of 45 degrees is easy. We don't need to determine the reference angle. We already know what it is. It's 45. So again, all of these angles that we can evaluate, their reference angles will either be 45 or 30 or 60. Okay, so that's what we're going to be looking for, right? Now, so we already have the reference angle. It's 45. I'll put that like in red here. Okay, so we're going to go to our 45, 45, 90 triangle right here, and we're going to just evaluate the sine of that 45 degree reference angle. So it's going to be opposite over the hypotenuse, so it'll be root 2 over 2. Okay, last thing I want to check is what quadrant is our angle in. The original angle of 45 degrees is in quadrant 1. All the trig functions are positive there, and so this will stay positive root 2 over 2. And we're done. Okay. Next, we'll do cosine of 60. Okay, again, 60 degrees. First thing we want to do is determine the reference angle. The reference angle there, okay, is 60, right? Again, 60 degrees is in that first quadrant, so 60 degrees will be what we evaluate. There's 60 degrees in our 30, 60, 90 right triangle, and so cosine is the adjacent leg over the hypotenuse. Oops, sorry. I'll put 60 degrees in parentheses there because that's where we're going to evaluate. And so adjacent leg over the hypotenuse, 1/2 over 1, which is just 1/2. Again, we'll check for the sine, okay? And so it's 60 degrees, that's in quadrant 1, and so we are going to be positive, and our final answer is 1/2. All right, next, number 3, tangent of 45 degrees. Okay, so these first 3 I made kind of easy because, you know, I wanted to kind of make sure we get our feet under ourselves before we get to the more difficult ones. The other ones aren't going to be that difficult, but also reference angle is 45 degrees. Again, that's the angle that's in the first quadrant there. That's, you know, the reference angle is really, you know, the nearest angle it takes to get you to the x-axis. So if our 45-degree angle is right here, you know, then it takes us 45 degrees to get back to that x-axis there too, right? So that's the idea there. So tangent, so we're going to use our triangle right here. Tangent is opposite leg over the adjacent leg, so it's root 2 over 2 over root 2 over 2, but they're the same thing. They just cancel out and they just give us 1, okay? We're in the first quadrant, again, because that original angle was 45 degrees. All the trig functions are positive there, and so it just stays a positive 1. All right, now let's do one like sine of 225 degrees. This, okay, is not a reference angle, right? 225 is too big. Okay, our reference angles are always going to be an angle there in that first quadrant. It should be an angle measure that fits in the first quadrant, right? We want to determine, is it a 45, is it a 30, or is it a 60 for our reference angles there. So 225, well, let's draw a little picture here of where 225 would be, just to kind of help us out. So from here to here is going to get us to 90. Then from here to here will be 180. Now if I go from here to here, that'll now be at 270. So let's see here. So this 225 is going to fit somewhere in between right here, we'll say. We'll say there's 225. Okay, now, the full angle around here is 225, right? What's the reference angle? Well, the reference angle is this little piece right here. So what is that? Well, what's the difference from 180 to 225? And the answer is 45 degrees. So there's our reference angle. It's 45. Okay, so we're going to evaluate sine of 225 like it's sine of 45. Okay, and so that'll give us the right ratio, and then it's just a matter of figuring out whether it's positive or negative, whether that ratio is positive or negative. So we'll go up here to the 45, 45, 90 triangle. We'll do sine. Sine is opposite over the hypotenuse, so root 2 over 2 over 1, so just root 2 over 2. Okay, now 225 is in the third quadrant here. It ends up in the third quadrant, which if we look right here, only tangent is positive there, okay, in that quadrant 3. And again, tangent's positive. Well, if you look, well, I'll talk about that in a little bit maybe. But tangent's positive, so sine will be negative there, negative root 2 over 2. And you can kind of tell because, okay, well, yeah, it's going to be hard to describe here without going too much more into it. Okay, sine's negative there. All right, only tangent's positive. And it has to do with the coordinates and things like that. Stuff we talked about from yesterday. Okay, by the way, an easy way to remember all of these places, like remember that all the trig functions are positive here. Sine's only positive, only tangent's positive, and only cosine's positive. Easy way to remember that is ASTC, all students take calculus. Okay, and that's one way you can help to remember the, all students take calculus, the order, of where those trig functions go and stuff like that. Okay, all right, and you'll notice here also, in 1 and in 4, both of them were asking sine, and both were sine of 45 degree was the reference angle. And you'll notice for the reference angle of 45, both result in root 2 over 2. The only difference is the SIGN, whether it's a positive or whether it's a negative ratio, right? That's the only difference. So if you have the same reference angle for two angles and you take the sine of them or the cosine of them or tangent of them, okay, the sine of two angles with the same reference angle, it'll be the same ratio, okay, the same numbers here. It'll just be whether it's positive or negative is that all that will change, okay? So let's try tangent of 300. Now 300, it is, again, we'll just draw a little picture here. So again, 90, 180, 270. We need to get to 300 though. So if I go the full way around, that's 360. So in other words, 300 is like somewhere in here. Okay, so if that's 270 and that's 360. So if we go back 60 degrees, okay, our reference angle is 60 degrees. Now you might be like, but Mr. Wig, couldn't we go back 30 degrees this way? And that would be true, right? You can go back 30 degrees, but a reference angle is always from the x-axis. You want to measure it from the x-axis. So don't measure here, okay? You want to measure from the x-axis. So this piece right here, which is 60 degrees, okay? We're always measuring from the x-axis like we did over there, okay? So 60 degrees is our reference angle. So you go up to our 30, 60, 90 right triangle here. There's 60. We're going to do tangent. So tangent is opposite over adjacent. So root 3 over 2 over 1/2. But again, instead of dividing, we'll change it to multiply by the reciprocal. So it's root 3 over 2 times 2 over 1. The 2's cancel, and so we'll have just root 3. Okay. Now, is it positive or negative? Well, 300 degrees is in quadrant 4. And in quadrant 4, only cosine is positive. So tangent, which is what we're evaluating here, will be a negative. So we'll make it a negative root 3. Okay? But you'll notice here that any tangent of any angle that's got a 60-degree reference angle will always be this root 3. It's just whether it's positive or negative then, furthermore. All right, last one here. Oh, I got 3 more. Sorry. I'll move on a little bit faster here. All right, 135. Where is that going to be? Well, it won't be in quadrant 1, right? So from here to here is 90, then here to here would be 180. We don't want 180 though, right? So 135 is going to be like right there. And so again, what's this reference angle here to the x-axis? It is 45 degrees. Again, because if that's 180, it's going to take us 45 to get to there. So this is really like evaluating cosine of 45 degrees. Okay, cosine of 45. Well, cosine is adjacent over the hypotenuse, so it's root 2 over 2 over 1. So it's just root 2 over 2. And then is cosine positive or negative? Well, we're in quadrant 2. Only sine's positive, so this will be negative. Okay, 2 more. Cosine of negative 210. Oh, Mr. Wade, you had to throw a negative 1 at us. Yes, I did. Okay, so remember, for a positive angle, we rotate counterclockwise, right? But for a negative angle, we rotate clockwise. Okay, so 210. So from here to here, it'll be negative 90, negative 180, negative 270. So that negative 210 is going to fit right in here. Okay, what's the reference angle? Well, again, if this was negative 180 right here, then to get to that negative 210, how much further do we have to go? We got to go negative 30 more, right? So 30 is our reference angle. Okay, so this is like evaluating cosine of 30 degrees. Okay, cosine 30, go back up here. Cosine right there is adjacent over the hypotenuse, so root 3 over 2 over 1. Okay, like that. And then we are in what quadrant? We are in quadrant 2. Okay, as a result, and so only sine is positive in quadrant 2, so this will be a negative root 3 over 2. Okay. All right, last one here, tangent of negative 450 degrees. So negative 450, that's really big. So let's see here. So again, we'll kind of draw this. So negative 450, so this will be negative 360. If I go 90 more, now I'll be at negative 450. Okay. Ooh, and actually I don't want to talk about this angle just yet, because we haven't talked about what happens when we end up on the quadrant like that. So let me change this to, like, I don't know, negative 405 degrees or something like that. Okay, so negative 405 degrees will get me to right here. Okay. It's between the negative 360 and negative 450. And so, again, what is this reference angle right here? How do we get from this terminal side to the x-axis? Well, it's a difference of 45 degrees. Okay, so this is like evaluating tangent of 45, which is, well, going back up here, tangent of 45, opposite over adjacent, so root 2 over 2 over root 2 over 2. Which all simplifies out to just 1. We're in quadrant 4, and in quadrant 4, only cosine is positive, so this will be a negative 1. Okay, and again, you can check all these answers with your graphing calculators if you want to, but hopefully that helps a little bit more. I'll give you a few more problems like this for homework. Thanks for sticking with me, guys. We'll probably do one more day of this in our next lesson. just to be comfortable. We'll look at doing radians, and we'll also look at what happens when we end up like on the axes and stuff like that there. All right, thanks for sticking with this, guys. Again, message me if you have any questions, and we'll go from there. Thanks, bye.